What's up, guys? Sheldon and Arthur here, coming at you with a live APM demo of MicroAI.
That's right, everyone. With MicroAI, you can ingest all different types of sensor data into an AI engine. It'll create some output that can be used in a million different types of applications.
So, quick disclaimer here: if you have not gone through the SDK documentation, have not purchased and received your Raspberry Pi, have not installed the assets and packages on the Raspberry Pi, done all of that prep work that's documented within the SDK README files, please go do that now. Stop this video; it will not help you. But without further ado, let's go and get started on this APM demo.
Alrighty, so first thing, let's go into the directory that has our MicroAI and APM files. In our case, that is the APM directory. Here you'll see all of the files you need to run MicroAI. For this demo, we are going to be training a Raspberry Pi to move in a certain pattern and then therefore follow certain positional forms. And then when it goes to a different position, you would see different alerts and other things show up. So in order to do that, we have to set up certain sensors to send data and have data be ingested by the AI engine. We can see exactly how that happens in our local lib1.py file. So let's go into there. This is an example of MicroAI Xcode.
So the Xcode, for all intensive purposes, is just going to be your inputs.
That's right, everyone. So in this case, our Xcode is set up to use the sensor, the sense hat. From the sense hat, we are getting acceleration and gyroscopic measurement values on the X, Y, and Z axes. So that's a total of 6 different channels of data. And we actually did some feature engineering on top of that so that we get the change in those values over time instead of just those raw values. That way, MicroAI has a more centered idea with each of those values so that any change is a bigger jump, and that can be identified as abnormal more easier by the AI engine. So that's just an example of feature engineering that can be done in all different types of Xcode for different deployments. As in every other type of Xcode, we end with the result equaling all the different channel values, and before that, the time.time value. And this can be sent on whatever frequency you set in the configuration files. So that's our Xcode. We can run our AI engine from here, but before that, let's go ahead and look at and run our Y code examples.
So again, guys, Y code, for all intensive purposes, is going to be your outputs. This is what we allow you within the SDK documentation to edit, to create your own use cases and kind of turn it into your own thing. So for this tutorial, we'll show you the our APM Y code, but please feel free to edit the Y code and adjust it however you see fit to fit your use case.
Absolutely. Let's go back into the APM directory where all of our MicroAI files are. Here we're going to go into the Y code subdirectory. And the first piece of Y code we're going to look at is called new light. So let's nano into the new light.py file. Here you'll see that we're actually not only using the sense hat for its sensors attached to it for acceleration and gyroscopic measurements, but also we're using the light on the sense hat for our output. So we're importing sense hat again, and then we're also importing the MicroAI library, MicroAI output, from there the MAI class, which has a few different functions from which you can create some valuable applications. So we're setting our device that uses the MAI functions as the local host, so running on the edge. We're setting up our sense hat and the colors that we want the sense hat to change based on our different set of logic. The logic for this involves one of the MAI functions, and that function is abnormal. Basically, isAbnormal tells you for each channel whether yes or no in that second if it is acting normal or abnormal. So in this case, if we were to print is abnormal by itself, you would see 6 different values and zeros or ones for those values. Ones when we're getting some abnormal behavior readings from that channel. So this logic involves us adding all of those values together, and if they're greater than 0, making the sense hat red. Basically meaning if any of the channels are deemed abnormal by the AI, let's make that sense hat red, otherwise we can have it be green. So that's one set of Y code, and let's go ahead and run it now to set up our light. And now our light is going, so we can go to our second set of Y code. Here we're going to go back into the directory with all of our MicroAI files, in this case APM, back into the Y code subdirectory, and here we're going to look at the APM Y code file. So let's nano into that. So it's very similar to that earlier light file. We're importing from the MicroAI output library, setting up the device that is running on the edge, as we can see with the localhost configuration. In this case, we're going to print test is abnormal. So for our local device, we're going to see all the channels, those 6 channels, and whether 0 or 1, they're acting normal or abnormal. We're going to print the sum of that as well. And if that sum is greater than 0, if any of those channels are abnormal, we're going to print that the device needs maintenance. Otherwise, we're going to print the device is okay. And this is going to happen on a 1-second basis. So now we have an understanding of that. We can go ahead and run that Y code as well. And I'd like to note that we actually haven't started the AI engine yet. So these are all kind of the filler values. And I'm going to make sure I'm running it with Python 3.
So what we're essentially seeing here, guys, again, just to reiterate the Y code, is that we're seeing the comment of this device is okay. If this was abnormal, we would receive a comment of the device needs maintenance, and then we see an array of zeros and ones. Essentially, ones reading abnormal, zeros reading normal. If there's more ones than there are zeros, then the device will turn red, and it will read as an abnormal behavior. Another way to put this in this use case would be that if the Raspberry Pi breaks the movement pattern, MicroAI will detect that as an abnormal behavior, and then turn the light to red as well as post a comment saying that the device needs maintenance.
Right. So now that we have our Y code set up, we can go ahead and run the AI engine. So while I'm running it, I'll make sure that my device is moving in the same pattern that it had been moving in during the training time. So let me go over there. I'm moving to my device normally. I'm going to do Python 3. This is the AI engine file. So now that I'm moving my device in the way it should be moving, and I'm running the AI engine, now we have the AI engine going.
So in order to get this normalized, we'll see that the device needs maintenance initially. Once the data has normalized to the movement, it should go back to reading the device is okay.
Yes. So we're getting some normalized values now. I'm going to keep on moving it in this pattern in the normal state. So soon we'll see fewer and fewer of the little abnormalities as read at startup, and it'll be actually reading what the AI thinks is normal and not normal. So right now I haven't done anything different but the normal pattern. So normally you have to give as much time as you can in terms of normalization time in order to avoid these kind of these quirks that happen at startup. Once we feel like we're at a good level, then we can definitely get started with the example of abnormal behavior.
So it seems we seem to be receiving a fairly low amount of device needs maintenance. The device seems to be okay for the most part. So now let's show you what this looks like whenever we break the pattern.
All right, and here we are about to break that pattern.
And so we see a number of device needs maintenance coming in. And then as the data begins to normalize again, and we begin to resume the previous pattern, MicroAI reads this as normal, and it goes back to behaving normally. So that's it for this APM tutorial, guys. Please, if you have any questions, any at all, please visit the onetech.ai website. Go to the developer portal. This should answer any and all questions for you there. And good luck, guys, and happy coding.
Happy coding, everyone.